Have you ever looked out your window in the dead of night, stared up at the scattered stars, and felt the deep, profound stillness of the world? It is a beautiful lie. For the vast majority of human history, our ancestors gazed upward and carved their absolute certainties into ancient stone and parchment, entirely convinced that the earth was a solid, unmoving anchor. They believed we lived beneath a perfect, unchanging canopy, a cosmic painting hung entirely for our comfort. But the quiet safety you feel around you is arguably the most brilliant illusion the cosmos has ever designed. As you lie in your bed right now, perfectly still, with your eyes growing heavy and your breathing steady, you are not at rest. At this very second, you are hurtling through a pitch-black void at millions of miles an hour, swept up in a hidden motion so massive that it defies human imagination. The ground under your home does not shake, the stars outside do not blur past you, and yet, absolutely nothing is standing still. Welcome to Bedtime Universe. Tonight, we are going to tear down that painted sky and map the true currents of the cosmos. We will trace the forgotten footsteps of those who first realized the heavens were moving, and we will follow the invisible forces dragging our entire world toward an unfathomable destination. So, pull your blankets close, let your muscles relax, and allow the mysteries of the dark to wash over you. If you find peace in the boundless wonders of space, please subscribe to our channel and let our voice guide your dreams every single night. Close your eyes and sleep well as we embark on the ultimate journey to find out exactly where everything in the universe is going. Long before the cold metal of our modern telescopes ever pierced the darkness, our ancestors sought comfort in the warm embrace of an unmoving world. If you were to walk out into a quiet field thousands of years ago, feeling the solid, unyielding soil beneath your bare feet, you would have absolutely no reason to doubt your own senses. During the bright hours of the day, you would watch the sun rise in the east, climb triumphantly to its zenith, and sink into the west, all while clouds drifted peacefully overhead. And when the twilight faded into a deep, velvety indigo, you would witness the moon gliding smoothly across the sky, accompanied by a scattering of brilliant stars that stretched out like a gigantic, ancient, cosmic painting. The constellations faithfully returned, season after season, year after year, maintaining their familiar shapes without fail. Everything in the heavens appeared to be in motion, dancing in perfect circles, while the earth remained profoundly still. For millennia, the dominant view of the cosmos naturally placed humanity at the absolute center of everything. This deeply comforting perspective was shared across the ancient world, echoing through Chinese sky lore and Mayan cosmology alike. It made perfect sense of the changing seasons, the sudden darkness of eclipses, and the shifting alignments of the planets. It was a world view born not out of a lack of imagination, but because it aligned flawlessly with what the naked eye could perceive. It provided a profound sense of security, offering a stable world beneath our feet, surrounded by orderly, predictable skies. But it was within the Hellenic world that this poetic myth was crystallized into a rigid, technical, cosmological model, a mathematical cage that would hold human thought captive for centuries. The architect of this magnificent celestial prison was a scholar named Claudius Ptolemy, who lived in Alexandria around the 2nd century of the Common Era, during the absolute height of Roman Egypt. Ptolemy was a mathematician and an astronomer who possessed a burning desire to make sense of the skies, not merely through philosophical musings, but with the cold, hard precision of numbers. Surrounded by the fading glory of Alexandria, with its ancient libraries and flickering oil lamps, he inherited a vast and rich tradition of astronomical knowledge. Piecing together Babylonian star catalogs, ancient Egyptian astronomy, and the elegant geometric modeling of the Greeks. What he did with these fragmented observations was nothing short of monumental. He meticulously compiled, organized, and refined this knowledge into a singular, massive body of work known to history as the Almagest. This text was so profoundly influential that it would serve as the definitive, unquestioned guide to the universe for over 1,000 years. When you open the pages of Ptolemy's universe, you find a world defined by absolute, unshakable order. In his model, the Earth sat proudly at the very center of all things, perfectly still and completely unmoving. Around this heavy center, everything else in existence revolved in perfectly concentric spheres. Moving outward from our world, the spheres carried the Moon, Mercury, Venus, the Sun, Mars, Jupiter, and Saturn, culminating finally in the great enclosing sphere of the fixed stars. Beyond that final starry shell, there was absolutely nothing that the human mind could comprehend. It was a universe envisioned as a colossal set of nested, transparent, crystalline spheres, each spinning smoothly and silently around humanity. The stars themselves were believed to be physically affixed to that outermost shell, which majestically rotated once every single day to bless the earth with the rhythm of day and night. This was not merely a random, imaginative guess born from superstition. Ptolemy utilized real, physical observations to ensure his model was mathematically functional. He was heavily influenced by the Greek philosophical doctrine that the heavens must operate in perfect circles, simply because the circle was considered the most divine and perfect geometric shape in existence. However, reality is rarely as clean and perfect as mathematics desires, and this rigid belief in perfect circles created a deeply frustrating problem. As ancient sky watchers tracked the wandering paths of the planets night after night, especially the reddish glow of Mars, the bright presence of Jupiter, and the pale light of Saturn, they noticed an incredibly strange and rebellious behavior. Periodically, these planets would appear to slow down in their journey across the sky, grind to a complete halt, and then inexplicably move backward for a time before eventually stopping again to resume their forward path. This bizarre phenomenon, known as retrograde motion, made absolutely no sense if one clung to the belief that all planets were simply moving in simple, uniform circles directly around the Earth. To salvage his perfect model, to fix this cosmic glitch, Ptolemy was forced to introduce a brilliant but incredibly convoluted mechanism known as epicycles. He proposed that the planets did not merely travel in a single, massive circle around the Earth. Instead, he argued that each planet traveled along a small, circular path, the epicycle, while the center of that smaller circle orbited the Earth along a much larger, primary circle called the deferent. So, a planet was essentially circling an invisible point in empty space, and that empty point was circling the Earth. This dizzying, looping motion mathematically recreated the backward celestial steps that observers were seeing in the night sky. And yet, even with this dizzying complexity, the numbers still refuse to align perfectly with the stubborn reality of the heavens. So, Ptolemy introduced yet another heavy-handed mathematical tweak, a concept he called the equant. This was an entirely imaginary point located just slightly off-center from the Earth. Ptolemy claimed that if an observer were to measure a planet's motion from this invisible equant point, rather than from the actual physical center of the universe, the planet's movement would finally appear uniform. It was a breathtaking piece of mental gymnastics, a desperate attempt to force the universe to behave according to human philosophy. But it worked. This model, with its loops within loops and its offset imaginary centers, was refined, polished, and furiously protected for centuries. It shaped the creation of calendars, dictated the rhythms of timekeeping, fueled the fires of astrology, and entrenched religious worldviews across continents. It served mighty empires and guided devout scholars, perfectly explaining the skies for over 10 centuries. Humanity went to sleep every night feeling safe, cradled in the very center of a closed, finite, and perfectly engineered cosmic clockwork. The crystalline spheres kept the terrifying vastness of the unknown at bay. But an illusion, no matter how beautiful or how heavily fortified with mathematics, cannot hold back the truth forever. As time slowly marched forward, observers hidden away in monasteries and scattered across ancient observatories were quietly beginning to notice the cracks in the crystal. They were starting to ask hard, dangerous questions. They were looking for a simpler explanation, an explanation that did not require invisible points and endless loops to function. The perfect stillness of the earth was about to be shattered, and the human race was entirely unprepared for the sheer, terrifying scale of the motion that was waiting to be unleashed. The great unraveling of the motionless universe did not begin with a loud declaration or a chaotic rebellion in the streets. It began in absolute silence, hidden away in the damp, quiet halls of 16th century Europe, where the slow scratching of a quill on parchment was about to shake the very foundations of human understanding. The revolution was sparked in the year 1543 with the reluctant publication of a book titled On the Revolutions of the Celestial Spheres. The author of this monumental work was not a famous radical thinker seeking to overturn the world, but rather a quiet, unassuming priest named Nicolaus Copernicus. In those days, this was not unusual, as the church was the absolute epicenter of intellectual life, and monasteries were the great libraries and laboratories of their time. Born in what is now modern-day Poland, Copernicus was a man of vast and varied intellect who studied law and medicine, dabbled in economics, and became entirely fluent in Greek and Latin. But his true burning passion was not found in the texts of law or the herbs of medicine. It was found far above him in the cold and sweeping arch of the night sky. For many long years, he had been quietly collecting observations, running painstaking calculations by the dim light of a candle, and carefully nurturing an idea that had been slowly forming in his mind. It was an idea so profound and so dangerous that it went against absolutely everything he and the rest of the world had ever been taught. His theory completely challenged the entire system of nested spheres and motionless Earth that people deeply believed in. And because of this terrifying weight, he kept it mostly to himself. For decades, Copernicus hesitated in the shadows, intimately knowing the immense risks involved, which included not just harsh scientific criticism, but profound religious and political backlash as well. It was only near the very end of his life that he finally, and somewhat reluctantly, allowed his idea to be published and shared with the world. In those fragile pages, he outlined a radically new model of the universe, where the glowing, radiant sun, and not the heavy Earth, was seated at the absolute center of everything. The Earth, he boldly declared, was merely a planet, just like the wandering lights of Mars and Jupiter, and it orbited the sun once every single year. But Copernicus did not stop at simply moving the center of the cosmos. Based on his meticulous observations, he proposed 3 distinct and continuous motions for the Earth, forever shattering the illusion of our absolute stillness. First, he argued that the Earth rotates on its own axis once every 24 hours, and it is this daily spinning motion that makes the stars falsely appear to rise and set across the sky, rather than the heavens themselves turning around us. Second, he stated that the Earth revolves around the sun in a yearly orbit, a massive journey that beautifully explains the changing positions of the other planets and the cyclical arrival of the seasons. And third, he proposed that the Earth wobbles very slightly as it moves through its orbit, tracing a small, slow circle over long periods of time, a subtle motion that we now recognize as the tilt of the Earth's axis and the slow phenomenon of precession. These groundbreaking ideas were far from random guesses in the dark. Copernicus spent decades of his life developing deeply complex geometric models and vast astronomical tables, using the intricate tools of trigonometry to calculate the relative distances of the planets from the sun. He meticulously ordered the planets based on how fast they appeared to drift across the starry background, realizing that the closer a planet was situated to the sun, the faster it completed its orbit. This elegant arrangement lined up beautifully with what his eyes observed. And yet, despite the profound conceptual leap of this heliocentric model, it strangely did not significantly improve the accuracy of astronomical predictions. The haunting flaw in his magnificent design was that Copernicus was still deeply bound by the ancient philosophical belief of Ptolemy, assuming that all planets must naturally move in perfect, divine circles. Because he clung to this geometrical perfection, his mathematical predictions were only about as good as the old, convoluted system, and in some frustrating cases, they were even worse. The world was conceptually moving, but the mathematics of that motion were still trapped in an ancient cage. The tool that would finally break that cage did not come from a philosopher or a theoretical mathematician. It began quite humbly as a simple Dutch novelty, just a few glass lenses slapped together in a tube by spectacle makers trying to bring distant ships a little closer. But when the news of this strange, magical device traveled across the continent and reached Italy, one man saw far more than just a fleeting optical trick. His name was Galileo Galilei, and while he did not invent the telescope, he masterfully transformed it from a parlor toy into a serious, universe-altering scientific instrument. In the year 1609, Galileo took his refined tube of glass and did something revolutionary. He pointed it directly up toward the heavens. What he witnessed through that small eyepiece would brutally rattle the old, comfortable order of the cosmos. First, he aimed his gaze at the pale, silvery glow of the moon. Under the magnification of his lenses, it was immediately clear that this was not the perfect, smooth, unblemished divine orb that ancient philosophers had stubbornly believed in for millennia. It was deeply scarred with violent craters, towering mountain ranges, and long creeping shadows cast by the sun. It looked shockingly rugged and earthly, a physical place rather than a divine symbol. Then he shifted his telescope to the bright, steady light of Jupiter, and there, delicately dancing around the massive planet, he spotted 4 tiny, distinct points of bright light. Night after patient night, Galileo tracked their movements, watching, and they constantly changed their positions, but always remained tethered to the gravitational pull of Jupiter. He realized with absolute awe that these were moons, actively orbiting a celestial body that was not the Earth. This was an unimaginably huge discovery because the rigid geocentric model demanded that absolutely everything in the universe had to orbit the Earth alone. But right before his eyes, Jupiter was brazenly stealing that spotlight, parading its own majestic system of orbiting bodies. If the Earth was not the only center of motion, the entire ancient structure began to crumble. Galileo then turned his instrument toward the brilliant evening star of Venus, and that observation sealed the fate of the old world. He watched in absolute fascination as Venus went through distinct phases, waxing and waning exactly like the moon. Sometimes it appeared as a full, brilliantly illuminated disk, and other times it was reduced to a slender, glowing crescent. This phenomenon only made logical, geometric sense if Venus was traveling in an orbit directly around the Sun rather than around the Earth. If Venus circled the Earth, trapped inside our sphere, human observers would only ever see it illuminated from a single angle in one unchanging phase. But if it circled the Sun, and our Earth was also moving through space around that same radiant fire, then the complex geometry of light and shadow worked out perfectly. That little glowing dot changing its shape in the dark definitively proved that the quiet priest Copernicus had a very valid point. We were not the center, and we were certainly not sitting still. But even with the visual evidence provided by Galileo's brilliant glass lenses, someone still needed to definitively crack the stubborn mathematical code of the heavens. That monumental task fell to a man who, ironically, did not even fully believe in the Copernican system at first. Johannes Kepler was a deeply religious, intensely curious, and painfully precise German mathematician and astronomer who saw the universe as a grand manifestation of divine geometry. His life changed forever when he received his big break and became the dedicated assistant to Tycho Brahe, widely considered the last great naked-eye astronomer in history. Brahe was a flamboyant and wealthy Danish nobleman who had spent decades meticulously collecting the absolute most accurate measurements of planetary motion ever recorded, doing all of this without the aid of a single telescope. On his secluded island observatory, Brahe built gigantic, magnificent instruments and charted the shifting positions of the planets with a level of mind-numbing precision that no one had ever achieved before. Interestingly, Brahe firmly refused to buy into the heliocentric model of Copernicus. Instead, he formulated his own incredibly awkward hybrid theory, where all the other planets obediently orbited the Sun, but the Sun itself faithfully orbited a completely stationary Earth, desperately trying to split the difference between new data and old comfort. But when Brahe passed away in the year 1601, he left his mountain of priceless, incredibly precise data to Johannes Kepler, and Kepler immediately dove into the numbers with a frantic obsession. He spent years of his life tirelessly trying to force the Copernican system of perfect circles to match Brahe's impeccable data, focusing especially on the notoriously difficult orbit of Mars. Mars was an absolute nightmare for astronomers. It was tricky. It sped up. It slowed down. And it traced those bizarre, looping paths across the night sky. No matter how hard he tried, Mars simply would not behave. For agonizing years, Kepler stubbornly tried to force the mathematical data into circular orbits, because that was what absolutely everyone assumed must be true. Circles were considered sacred, divine, and mathematically perfect, so the heavens logically had to move in circles. But Mars did not care about human philosophy, and the numbers refused to lie. Finally, exhausted and humbled by the unyielding reality of the universe, Kepler stopped forcing the math to fit his beliefs, and he allowed the cold, hard data to finally speak for itself. What that data whispered to him from the pages of Brahe's ledgers changed human history forever. Kepler discovered that the planets do not move in perfect divine circles at all. Instead, they stretch out and move in elegant ellipses. This monumental realization became his first law of planetary motion, stating clearly that all planets move around the Sun in elliptical orbits, with the massive Sun sitting off-center at one specific focus of that elongated oval shape. Suddenly, the agonizing discrepancies vanished. The math worked flawlessly. Kepler then noticed something else deeply profound, buried in the numbers. The planets do not lazily drift at constant unchanging speeds. They dynamically sweep across the vacuum of space much faster when they are pulled closer to the Sun, and they significantly slow their pace when they swing farther away into the cold dark. This elegant cosmic rhythm became his second law, demonstrating that an imaginary line connecting a planet to the Sun sweeps out perfectly equal areas of space during equal intervals of time. In simpler terms, as a planet moves along its stretched-out elliptical orbit, the invisible pie slice of area it covers in, say, a month, is always exactly the same mathematical size, whether the planet is rocketing near the burning Sun or creeping along far out in the frozen distance. This beautiful shifting momentum perfectly explained the strange and frustrating speeds of the wandering planets, especially his tormentor, Mars. And then, like a grand symphony reaching its final crescendo, came his third law, often known as the law of periods, the invisible thread that beautifully stitched the entire solar system together into one cohesive, predictable machine. Kepler calculated that the square of the orbital period of any given planet is directly and flawlessly proportional to the cube of the semi-major axis of its orbit. In far simpler terms, he mathematically proved that the further out a planet lives from the heat of the sun, the longer its orbital journey takes. And this relationship is not random, but perfectly, rigorously predictable. Together, the sweeping vision of Galileo's telescope and the flawless precision of Kepler's equations did something truly extraordinary for the human race. One gave the people the literal vision required to see a new, moving universe, while the other finally provided the inescapable mathematics necessary to prove it. Copernicus had quietly started the fire in the dark. Galileo had boldly fanned the flames with his lenses, and Kepler had meticulously forged the structural framework that finally made the blazing truth hold strong against the collapsing weight of ancient history. The transparent, crystalline spheres that had supposedly held the universe together for thousands of years were thoroughly shattered. The comforting stillness was gone forever. Humanity was untethered, spinning on a tilted, wobbling rock, flying at unimaginable speeds around a fiery star, finally awake to the dizzying, magnificent reality of a universe in motion. Once the heavy, ancient door of a stationary universe was forced open, the human mind rushed through the gap and immediately began pushing even further into the dark unknown. The transparent, crystalline spheres that had safely contained human thought for over 1,000 years were now nothing more than an imaginary ruin left behind in the dust of history. We were adrift. We were no longer the motionless anchor of creation. We were fragile passengers on a giant, spinning rock hurtling through an endless void. This terrifying revelation birthed an entirely new generation of profound, desperate questions. If there were no solid glass spheres holding the heavens together, then why do the planets move at all? What invisible tether keeps them safely bound in their elliptical orbits? Why doesn't the Earth simply break free from its path and fly off wildly into the freezing, eternal blackness of deep space? Or conversely, what prevents us from suddenly plummeting inward, drawn to our doom in the burning, apocalyptic fires of the sun? The sky was no longer a painted ceiling. It was an open abyss, and humanity needed to understand the hidden mechanics of this terrifying new freedom. The answers to these towering cosmic mysteries did not ultimately come from an astronomer pointing a massive glass lens upward into the glittering night. Instead, the profound truth of the heavens was unraveled by a deeply solitary mind looking downward at the simple, quiet nature of the earth. It is here that the famous, almost mythical story of the falling apple gently enters the narrative of human discovery. Whether you imagine him sitting in the dappled shade of a quiet English orchard, or simply pondering the mundane realities of weight and matter in a dark room, Isaac Newton realized something so fundamentally brilliant that it would forever alter the trajectory of our species. Newton observed the mundane fall of an object and gave the invisible force pulling it downward a powerful, enduring new name: gravity. But his true genius lay not just in naming this familiar force, but in boldly expanding its dominion across the entire infinite expanse of the universe. In a flash of unparalleled insight, Newton realized that the exact same invisible force that relentlessly pulled ordinary apples from the branches of earthly trees was also reaching out across the vast, empty gulf of space. This silent force held the pale, heavy moon firmly in its orbit around the Earth. It was the very same force that kept our massive spinning planet tightly circling the radiant sun, and it ruled the intricate, sprawling dance of all the other planets wandering through the darkness of the solar system. Before this breathtaking moment, humanity had strictly divided the universe into two entirely separate realms: the corrupted, heavy earth below, and the divine, perfect heavens above. But Newton shattered that psychological barrier forever. He formulated his grand realization into a mathematically rigorous concept known universally as the law of universal gravitation. According to this elegant, uncompromising law, absolutely every single object in the universe that possesses mass constantly pulls on absolutely every other object with mass. There are no exceptions, no divine exclusions. The rule was beautifully, brutally simple. The larger the mass of an object, the stronger and more dominant its gravitational pull becomes. Conversely, the farther apart these objects are scattered across the vastness of space, the weaker and more fragile that invisible pulling force becomes. It was an invisible web of attraction connecting every single atom in existence, pulling the cosmos into a delicate, vibrating state of perpetual tension. Armed with Newton's flawless mathematical equations, the chaotic, terrifying expanse of the solar system suddenly transformed into a perfectly understandable, highly predictable machine. Using the law of universal gravitation, scientists could now finally comprehend the sheer, staggering velocities required to keep our world alive and afloat in the dark. They calculated that our quiet, unassuming Earth is actually tearing through the vacuum of space, orbiting the sun at an astonishing speed of roughly 107,000 kilometers per hour. If that number is difficult to hold in your mind as you lie perfectly still in the dark, consider that it translates to hurtling through the blackness at nearly 30 kilometers every single second. In the brief moment it takes you to take a deep, slow breath and exhale, you and everyone you have ever known have traveled hundreds of kilometers through the void without ever feeling a whisper of the cosmic wind. And yet, we are not even the fastest passengers in this grand system. Mercury, a small, heavily scarred world trapped blisteringly close to the crushing gravity of the sun, is forced to move even faster. It races desperately along its tight orbit at around 47 kilometers per second, simply because it feels a much stronger gravitational pull from the nearby star. If it were to slow down even a fraction, it would be mercilessly dragged into the solar fires and instantly consumed. Mars, on the other hand, lingering much farther out in the colder, dimmer regions of the solar system, feels a weaker pull and therefore moves at a noticeably slower, more leisurely pace across the sky. The beautiful mathematical truth of the universe was finally laid bare for anyone willing to look. Everything fits perfectly together. The closer any planet dares to approach the massive gravity of the sun, the faster it absolutely has to move just to maintain its delicate balance and stay alive in orbit. Newton's rigorous mathematics definitively proved this delicate harmony, leaving absolutely no room for ancient myths or fearful guesswork. By mathematically defining this invisible, pulling force, Newton did something that philosophers had desperately dreamed of for thousands of years. He successfully connected the majestic, sweeping motion of the heavens above with the ordinary, everyday motion here on the dirt of the earth. For the very first time in recorded history, humanity possessed one single, unbreakable set of laws that applied equally to absolutely everything, everywhere. The terrifying, boundless abyss of space was suddenly tamed by the quiet power of human logic. The great looming cosmic mystery of planetary motion, the haunting questions of exactly why they move, exactly how they move, and precisely how fast they move, was no longer a frightening mystery at all. It was just gravity. The universe, it seemed, was not a chaotic, unpredictable storm of divine whims, but rather a colossal, flawlessly calibrated clock. The solar system was a magnificent machine, winding its way through the dark with absolute mathematical certainty. We were no longer at the center of the universe, but we had finally discovered the invisible clockwork that kept our tiny, fragile home perfectly safe as it sailed through the boundless night. This profound realization gave humanity a deep, quiet comfort to replace the one they had lost. The sun became our new, immovable anchor, the heavy stationary heart of the world, and we were safely tethered to its reliable light. But just as the ancient illusion of a still earth had shattered, this new, comforting dream of a completely stationary sun was only a temporary mirage. The universe is endlessly vast, and its capacity for motion was far greater, far deeper, and far more unsettling than anyone armed with a simple equation could have ever possibly imagined. The clockwork was ticking beautifully, but humanity was about to discover that the entire clock itself was drifting silently away into the unimaginable dark. After the monumental shock of the Copernican revolution finally settled into the collective consciousness of humanity, a new, fragile comfort began to take hold. The sun proudly took the Earth's former place as the absolute center of everything. No longer did the vast cosmos obediently revolve around us. Instead, it was understood that the Earth was the wanderer, spinning tirelessly on its axis and tracing a wide orbit around the burning star. This dramatic idea initially felt deeply revolutionary and terrifying, but once the great paradigm shifted, the new heliocentric model began to feel safe and familiar. The sun, which ancient eyes had once seen as merely another glowing object crossing the sky, became our new, reliable still point, the solid, motionless anchor of the entire universe. For a few hundred years, as generations lived and died beneath the slowly turning sky, that comforting idea held its ground. Humanity had simply traded one perfectly stationary center for another, allowing us to sleep peacefully in the belief that our solar system was firmly planted in the endless dark. But that temporary illusion of absolute stillness was destined to change, and the revelation would not arrive through the intricate mathematics of a physicist or the deep pondering of a philosopher, but rather through the sensitive, artistic mind of a musician. William Herschel was a man born in Germany who eventually moved across the sea to England, establishing a quiet life as a dedicated composer. Yet, beneath the beautiful melodies and the complex musical scores that filled his days, he harbored a quiet, burning obsession that would consume his nights, an absolute fascination with telescopes. he began building these magnificent instruments in his spare time, retreating into the quiet hours to tirelessly grind glass mirrors by hand. Through sheer determination and endless patience, he designed optical instruments that were vastly better and more powerful than almost anything else existing in his time. When Herschel took his masterful creations and pointed them upward toward the freezing, velvet expanse of the heavens, he did not just lazily admire the pretty, twinkling lights. He counted them. Herschel became utterly obsessed with the concept of underlying cosmic structure. As he stared into a sky that seemed completely flooded with an infinite number of stars, he dared to ask a brilliantly simple yet incredibly profound question. Were all of these glowing celestial bodies scattered at complete random across an infinite, chaotic void? Or was there a hidden, grand pattern dictating their placement? To answer this towering question, he decided to find out the hardest way possible. Alongside his deeply dedicated sister, Carolyn, who shared his intense passion for the night, he began a massive, grueling survey of the heavens. Night after freezing night, bundled against the cold English air, he would meticulously count the stars in incredibly narrow, deliberate slices of the sky, measuring just a few degrees wide. He would carefully and obsessively note exactly how many individual points of light he could see glowing in each specific direction. Over long, quiet years, these painstaking numerical counts began to paint a breathtaking picture of the darkness. He noticed something exceedingly strange buried in his ledgers. Some directions in the deep sky contained vastly more stars than others, creating dense walls of starlight, and the absolute highest density of these stars lined up perfectly with that faint, glowing band of cosmic dust we have long called the Milky Way. Using his rigorous mathematical star counts, Herschel boldly constructed a map, attempting to model what he genuinely believed was the true physical shape of the entire universe. The map he patiently drew did not show an infinite, boundless, random scattering of stars in all directions. Instead, it looked remarkably like a flat, stretched-out disk. It bore a striking resemblance to a massive grinding wheel floating in the void, with our warm, familiar sun placed roughly near its center. Today, with the immense benefit of modern science and powerful space observatories, we know that he ultimately got the sheer size of this structure wrong. He had absolutely no way to account for the thick veils of interstellar dust, the microscopic, shadowy particles floating between the stars that ruthlessly blocked many distant, glowing suns from his view. But for the late 1700s, this conceptual leap was absolutely extraordinary. Through immense patience and relentless observation, he had figured out that the stars were not completely infinite or scattered without purpose. They were actually part of a bound physical structure, a grand and cohesive system, and we were living deep inside of it. He proudly called this massive, glowing congregation of light the galactic system. Herschel did not know that it was merely one galaxy in the modern, expansive sense. As he firmly believed this sprawling system of stars constituted the absolute entirety of the universe, he did not yet realize that those faint, fuzzy patches of light drifting in the dark, the mysterious so-called nebulae, were actually entirely other galaxies, unimaginably massive and existing unimaginably far away. Still, what his tired eyes and his carefully ground lenses did reveal was undeniably revolutionary. He mathematically demonstrated that we were absolutely not sitting at the center of everything, not even close. And that massive flat shape he discovered floating in the dark meant something far more profound than just a beautiful astronomical map. It heavily suggested physical structure, specific orientation, and the terrifying potential for motion. If the Great Milky Way possessed a defined physical shape, then we possessed a very specific, localized location within it. And if we had a precise location within a massive, structured celestial system, then perhaps we were also in motion, drifting along with it through an even larger void. The comforting stillness of the sun was cracking, the anchor was lifting, and people slowly started asking a much deeper, far more terrifying question in the dark. Where exactly are we really located in this boundless expanse? And how can you ever possibly tell what is moving and what is perfectly still? If every single object in the heavens is moving, how can you ever truly know when something is finally still? This is not merely a lack of astronomical data. It is a towering wall of perspective, a fundamental trap built into the very nature of our existence. Every single thing we look at, every shimmering star and distant planetary shadow, is seen strictly from our isolated vantage point here on Earth. Our fragile human eyes, our delicate glass telescopes, and our most advanced electronic instruments are all securely bolted down to this violently spinning rock that is, in turn, constantly orbiting a heavy star that might also be moving. So, how do you untangle the great overlapping cosmic web and figure out what is genuinely moving in the dark? To understand this dizzying, philosophical puzzle, let us step away from the cold stars for a moment and engage in a simple, quiet thought experiment. Imagine that you are sitting entirely alone in a dimly lit train car late at night, surrounded by the gentle, rhythmic, comforting hum of the metal engine. You feel completely at peace in your enclosed cabin, perhaps casually sipping from a warm cup of coffee and reading a heavy book that rests calmly in your lap. You casually glance out the thick glass window into the pitch-black night and suddenly see another train idling on the steel tracks right next to yours. For a heart-stopping, disorienting moment, it looks exactly as though that neighboring train is slowly, silently sliding backward into the night. But then your mind falters. Your senses betray you, and you ask yourself an unsettling question. Are you the one moving forward, or is the other train moving backward? Or are both trains secretly gliding through the dark at different speeds? Without the crucial ability to look down and clearly see the solid, unchanging ground beneath the metal wheels, you are trapped in a terrifying void of context, and you simply cannot know for sure. This disorienting phenomenon is the inescapable trap of your frame of reference. From the safe, enclosed perspective inside your cozy train car, everything feels profoundly, perfectly still. The dark liquid coffee stays entirely flat inside the ceramic cup, and the printed pages of your book do not flutter even a fraction of an inch. But to a solitary, shivering figure standing out in the cold air on the station platform, you and your entire train are flying by them at 80 kilometers an hour in a blinding blur of metal, noise, and light. Who is right about the true state of the physical world? The deeply unsettling answer is that both perspectives are absolutely correct, because motion is not a rigid, absolute law of nature. It is entirely relative. When your only available window to the vast, sweeping cosmos is viewed from inside a moving vehicle upon a spinning Earth, orbiting a star that is also drifting, trying to untangle what is genuinely in motion becomes a nearly impossible puzzle. It was this exact, mind-bending puzzle that one incredibly quiet and patient man calmly set out to finally solve. Jacobus Kapteyn never once viewed himself as a loud revolutionary looking to aggressively overthrow the established heavens. He was simply a careful, meticulous man who lived in the Netherlands during the mid-19th century and passionately loved the quiet, unyielding certainty of numbers far more than the chaotic noise of human debate. By the time Kapteyn began his life's monumental work, William Herschel's groundbreaking maps of the stars were already over a century old, and the radical idea that we lived somewhere inside a massive star system, the sprawling structure we confidently call the Milky Way, was finally accepted as fact. But the detailed internal structure of that system, and more importantly, its hidden internal motion, remained a blurry, frustrating mystery. Telescopes had grown significantly better and sharper over the decades, yet astronomers did not merely need stronger lenses to pierce the dense galactic veil. They desperately needed an entirely new mathematical approach to the skies. That fresh, brilliant perspective is precisely what Kapteyn brought into the silent observatories of the world. Instead of merely mapping the raw brightness or the static, frozen position of a star in the sky, he started painstakingly collecting a highly subtle, elusive data point known as proper motion, which is the exact measurement of how stars appear to physically shift across the face of the sky over incredibly long periods of time. These shifting changes were unimaginably tiny, often measuring just fractions of a single arcsecond per year, a movement so staggeringly slight that the human eye could never possibly detect it over a normal lifetime. But Kapteyn knew that with the right rigorous mathematics and enough patient time in the dark, these microscopic shifts would inevitably tell a grand, sweeping story of cosmic currents. He meticulously gathered astronomical observations sent from remote, quiet observatories scattered all over the globe, pulling precious data from the Cape in South Africa, from Cordoba in Argentina, and from Sydney in distant Australia. Bit by agonizing, slow bit, he compiled vast, heavy star catalogs containing many thousands of celestial objects, rigorously measuring their individual brightness, charting their precise starting positions, and watching them silently drift across the decades. And then, slowly emerging from the endless, quiet columns of numbers, something incredibly strange finally showed its face to humanity. The distant stars floating in the dark were not just drifting at random like meaningless dust motes caught in a chaotic sunbeam. They were moving in highly coordinated, deliberate patterns. Two massive, general streams of stars, acting very much like deep, unstoppable cosmic currents flowing in a black ocean, seemed to drift predictably across the vastness of the sky. At first glance, this eerie, synchronized movement made it look exactly as though the stars were arbitrarily grouped into two large rotating swarms passing us by in the night. But Kapteyn stopped and thought much harder looking back at the fundamental trap of the frame of reference. He dared to ask another earth-shattering question in the silence of his study. What if this observed, sweeping motion was not actually about the distant stars themselves at all? To understand his brilliant conceptual leap, we must return to the concept of moving through a dark, crowded space. Imagine that you are walking steadily through a densely packed, busy plaza, completely surrounded by a heavy crowd of people. As you move forward, the people who are standing still or drifting slowly around you seem to be flowing past you in a dizzying array of different directions. But perhaps they are not the ones hurrying. Perhaps you are the only one in constant motion, and absolutely everything else in the plaza only appears to drift past you, simply because of your specific frame of reference moving through them. Captain made this exact, terrifying leap of logic for our entire solar system. He furiously ran the complex calculations, measuring the drift and the angles, and the numbers suddenly fit together like a perfect lock and key. The distinct, sweeping pattern of stellar motion he observed across the sky only made mathematical sense if our own supposedly stationary sun was actually moving forward and ruthlessly dragging the Earth and all the other helpless planets along with it for the ride. This monumental, newly discovered movement came to be known scientifically as the solar apex. According to Captain's impeccable mathematical results, our blazing sun was actively heading toward a specific, invisible point hidden deeply within the constellation Hercules. It was not a blazing, chaotic sprint through the void, but rather a steady, silent drift through interstellar space at a speed of about 20 kilometers every single second. With that one undeniable calculation, the magnificent sun permanently lost its ancient crown of stillness, and humanity was once again cast adrift on a moving vessel, sailing blindly toward Hercules. But Captain was not content to stop at merely moving the sun. He wanted to push his vision even bigger and mathematically map the entire ocean we were sailing upon. If we are constantly moving through a vast, sprawling field of stars, then what exactly is this colossal collection of light? What is the true, three-dimensional shape of the massive system we find ourselves trapped inside? Relying heavily on the observed motion and the fading brightness of the stars, Captain began mathematically constructing what he genuinely believed was the true shape of our entire star system. In his model, he logically assumed that stars were distributed relatively evenly across the freezing vacuum of space, and that their visible brightness faded in a completely predictable manner with distance. Based on those careful assumptions, he came up with a grand structural model of a flattened, disc-like shape spanning an impressive 40,000 light-years in size. And deeply embedded within this sprawling, majestic structure, what astronomers briefly referred to as the Captain universe, our moving sun happened to sit relatively near the center. This mathematical model represented humanity's very first real, data-driven attempt to map the absolute entirety of the Milky Way as a whole, cohesive object. Of course, in the unforgiving, sharp light of modern astronomy, we now know that Captain's universe was far too small to encompass the terrifying reality. He, much like Herschel before him, did not fully understand the deceptive power of interstellar dust. These microscopic, shadowy particles float heavily in the vast empty spaces between the stars, acting as a cosmic fog that actively absorbs and scatters fragile starlight, especially when looking tightly in the dense direction of the galactic plane. This invisible, suffocating fog maliciously dimmed faraway stars, making them appear mathematically closer to Earth than they truly were in reality. Because of this optical trick, his groundbreaking model ultimately underestimated both the true, sprawling size and the sweeping, elegant shape of our entire galaxy. But for its specific time in history, this map was an absolutely groundbreaking achievement of the human mind. It conclusively proved that the universe was a deeply unsettling place of endless, overlapping motion, where even the heaviest anchors were secretly drifting through a silent, unfeeling void, pulling us ever forward into an unknown destination in the dark. As the delicate internal structure of our own stellar neighborhood slowly began to reveal itself through the patient mathematics of earlier generations, a new and deeply unsettling mystery was already waiting in the cold, unyielding darkness of the deeper sky. For many years, as astronomers swept their heavy lenses across the heavens, they had repeatedly noticed faint, blurry spots scattered throughout the constellations, mysterious smears of light that they called spiral nebulae. Some observers confidently believed that these glowing, ghostly patches were simply turbulent clouds of gas and dust drifting safely within the familiar borders of our own Milky Way. But other, more radical minds harbored a quiet suspicion that something far more dramatic was hiding out there in the dark, harboring the terrifying thought that these glowing wisps might actually be entire star systems of their own, floating impossibly far away in a much larger void. This grand, silent debate hovered over the astronomical community like a heavy fog, waiting for a single, piercing beam of truth to burn it away. That profound turning point finally arrived in the towering, freezing mountains of Southern California, where the crisp, thin air provided a flawless window into the cosmos. It was here that Edwin Hubble firmly entered the picture, standing in the dark, open dome of the Mount Wilson Observatory. He was operating the majestic Hooker telescope, which was at that specific time the absolute most powerful telescope existing anywhere on the Earth. In the bitterly cold year of 1923, Hubble aimed this massive, mechanical eye at one of the most prominent and beautiful of those blurry anomalies, the great nebula known as Andromeda. As he stared deeply into the intricate glowing spiral of that distant light, he spotted something incredibly crucial hiding inside its dusty arms. A very specific, pulsing kind of star known scientifically as a Cepheid variable. The discovery of this tiny, flickering point of light might seem insignificant to a casual observer, but to Hubble, it was the key to unlocking the true size of the entire universe. To understand why this single, blinking star was so monumentally important, we must gently step back and honor the brilliant, painstaking work of Henrietta Swan Leavitt, a profoundly dedicated astronomer who had spent years staring at photographic plates in relative obscurity. Leavitt had brilliantly discovered that Cepheid variable stars brighten and dim in a strictly predictable, rhythmic pattern. Because of her monumental earlier work, astronomers now understood that this specific, pulsing pattern could be mathematically used to calculate exactly how far away the star truly was from the observer. Thus, pulsing stars acted as perfect, standard cosmic candles burning in the deep dark. By simply timing their gentle rhythm and measuring how faint they appeared to our eyes, you could mathematically derive their exact physical distance across the void. Armed with Leavitt's flawless mathematical yardstick, Hubble carefully tracked the flickering of the Cepheid variable hidden within Andromeda and crunched the heavy numbers. The final mathematical answer completely stunned him, leaving him standing in the freezing observatory with a truth that would shatter human history. Andromeda was not merely far away, it was resting way beyond the very edge of the Milky Way. The distance was so staggeringly vast, so completely unfathomable, that this glowing spiral could not possibly be a mere cloud of gas contained as part of our galaxy. This realization forced a massive, violent shift in the collective human consciousness. For long, quiet centuries, humanity had stubbornly thought that the sprawling Milky Way was the absolute entirety of the universe, a single, solitary island of light floating in an endless, empty ocean. But in one freezing night on a lonely mountaintop, Hubble proved that our massive, sprawling galaxy was just one single fragile island floating amongst an unimaginable multitude of many other galaxies in a vast, terrifying cosmic sea. But this profound discovery was not just about establishing distance. It provided humanity with a powerful new tool, because here is what truly matters when you realize you are not alone in the dark. By intensely studying these other, distant galaxies, we finally began to see our own home much more clearly. You cannot ever step outside to look at the majestic spiral of the Milky Way from the outside, because we live deeply trapped inside of it. It is exactly like trying to accurately map the sprawling, complex shape of a dense, overgrown forest while standing helplessly at the shadowy base of a single, towering tree. But with Andromeda and countless other distant galaxies suddenly revealed, we finally had something physical and beautiful to compare our home to. We could safely look at these alien galaxies completely from the outside and ask profound structural questions. Does our own galaxy have a sweeping spiral structure just like that one? Does it possess a glowing central bulge, a sprawling flat stellar disk, or a massive invisible halo of older stars? Over the next several decades, astronomers meticulously used this brilliant mirror effect, constantly comparing the shape of external galaxies to whatever fragmented data we could observe from deeply within the dusty arms of the Milky Way. They patiently mapped cold gas clouds, ancient star clusters, and the sweeping distribution of various stellar populations. They began to use the invisible power of radio astronomy to successfully see through the heavy, choking dust that stubbornly blocked our view in normal, visible light. Gradually, patiently, a new, breathtaking picture of our home emerged from the static. But Hubble was not finished tearing down the comfortable illusions of the human mind, because measuring the vast distances between these newly discovered island universes soon led to an even more terrifying question regarding their motion. To understand this next monumental leap, we must understand how light itself can behave like a compressed spring, changing its shape as it travels across the void. Imagine that you are standing quietly by the side of a long, lonely road, and a heavy car comes racing rapidly toward you, its large engine roaring loudly in the night. You have likely noticed that just as the vehicle passes you, the fundamental pitch of the engine noise changes drastically. It sounds much higher and more intense as it comes aggressively rushing in towards you, and then abruptly drops to a much lower, drawn-out moan as it rapidly drives away into the distance. This deeply familiar, everyday auditory experience is called the Doppler effect. It happens naturally whenever something that actively makes waves, like the physical vibration of sound, physically moves either toward you or away from your position. When the loud object is coming closer, the invisible sound waves physically bunch up and compress tightly together, resulting in a higher frequency. When the object is moving away, those exact same waves are violently stretched out and pulled apart, resulting in a lower frequency. But the profound magic of the universe is that light, which is also a wave, does the exact same thing as it travels across the black canvas of space. If a brilliant star or an entire sprawling galaxy is moving rapidly toward us, its delicate light waves get physically squeezed and compressed, effectively shifting the color of that light slightly toward the shorter, blue side of the visible spectrum. We call that specific phenomenon blue shift. Conversely, if that massive celestial object is moving rapidly away from us, the delicate light it emits gets physically stretched out over the vast distance, lengthening the waves and shifting the color toward the red side of the spectrum. That phenomenon is called red shift. In the busy, experimental decades of the 1910s and the 1920s, brilliant scientists slowly started utilizing this clever optical trick to carefully measure the exact motion of distant stars and galaxies. Hubble eagerly applied this technique to the faint, distant galaxies he had just proven were isolated island universes, and what he ultimately found buried in the spectrum of their light was absolutely shocking to the scientific establishment. As he measured galaxy after galaxy, the overwhelming majority of the massive star systems he observed were not simply sitting safely still in the dark, nor were they randomly drifting about like dust. They were moving deliberately, forcefully away from us. And he discovered a chilling, undeniable correlation that completely defied common logic. The farther away a galaxy happened to be from our Earth, the faster it was violently receding into the dark. Some of these massive glowing islands were flying away at speeds of hundreds of kilometers per second, while others, lingering near the edge of visibility, were racing away at thousands of kilometers per second. Hubble meticulously mapped this terrifying outward flow, and with absolutely each new distant galaxy he added to his growing charts, the inescapable pattern held up perfectly. Farther meant faster. This mathematical certainty could only mean one incredibly profound thing: a realization that was arguably one of the absolute biggest and most consequential discoveries in the entire history of science. It meant that the universe was not a static, unchanging box filled with drifting objects. It meant that space itself was physically expanding, stretching out in all directions at every given moment, and the heavy galaxies were simply just along for the ride, deeply embedded in a fabric that was constantly growing. This meant the universe must have had a definitive, explosive beginning. It meant that absolutely everything we can currently see today used to be crushed much closer together in a warmer, denser past, laying the fundamental groundwork for what would eventually become the Big Bang Theory. The comforting static void was gone, replaced by an aggressively expanding balloon of reality, pulling the distant lights of the universe further and further away into an unreachable, eternal cold. As you lie safely in the warmth of your bed, breathe deeply and imagine the space between the stars silently stretching. A gentle, unstoppable tide of darkness gently pulling the distant cosmos apart while you sleep perfectly undisturbed in the quiet night. As the dizzying reality of an expanding universe settled into the minds of astronomers, another profound mystery remained completely hidden within the dusty, spiraling arms of our own galactic home. A Dutch astronomer named Jan Oort took a much closer, deeply focused look at the intricate motion of the stars hovering near our sun, seeking to understand exactly how our immediate neighborhood behaved in the dark. He was not merely interested in strictly mapping where the stars were located, but rather exactly how they were physically moving through the void. What he ultimately found was incredibly strange and mesmerizing. If the Milky Way was rotating completely like a solid wooden wheel, absolutely every star should logically be moving at the exact same angular speed, just like the rigid spokes permanently attached to a bicycle wheel. But they were not behaving this way at all. Some stars were noticeably lagging far behind, while others were racing significantly faster across the dark expanse. It looked vastly more like a swirling liquid whirlpool than a solid mechanical wheel. Oort meticulously crunched the massive numbers and realized that the galaxy does indeed rotate, but it absolutely does not do so evenly. It rotates incredibly faster near its dense, glowing center, and much slower out at the cold, fading edges. From this elegant mathematics, he calculated that our own glowing sun is situated roughly 30,000 light-years away from the galactic center. And despite how perfectly calm and still your bedroom feels at this exact moment, our solar system is actually tearing through the vacuum at an astonishing speed of over 200 kilometers per second. That is a velocity fast enough to completely circle the entire Earth 7 times in a single minute. Even at that breathtaking, incomprehensible speed, the sprawling galaxy is so unfathomably vast that the sun takes roughly 225 million years to make just one single, full orbit around the glowing center. A grand period of time we now beautifully call one galactic year. Every single star you can see glittering in the night sky is faithfully doing the exact same thing, continuously spinning around the mysterious center of the galaxy, exactly like a swarm of bees buzzing around a colossal, invisible hive. But if absolutely every star is caught in this massive swirling orbit, what exactly is sitting in the dark center, anchoring this entire magnificent dance? To answer that terrifying question, astronomers desperately needed better, sharper eyes, ones that could successfully pierce and see clearly beyond the fragile spectrum of visible light. They turned to the invisible, silent power of radio waves, specifically mapping out the faint, natural radio signal gently given off by completely neutral hydrogen atoms. At a specific wavelength of 21 centimeters, this ghostly signal possessed the magical ability to pierce straight through the thick, choking clouds of interstellar dust that made normal optical observations nearly impossible. It was exactly like trying to accurately draw a detailed picture of a dense, shadowy forest while you are standing blindly inside the dark woods. But now, humanity finally possessed the precise tools required to do it. This monumental effort eventually led to one of the absolute biggest technological leaps forward in human history: the creation of the Very Long Baseline Array, or the VLBA. The VLBA is not just a single, lonely telescope pointed at the dark. It is an incredibly complex, interconnected system of 10 separate radio antennas spread meticulously across thousands of kilometers of the Earth's surface. By perfectly syncing these massive metal dishes scattered across the entire Western Hemisphere, scientists effectively formed one colossal super instrument that was capable of resolving incredibly small, delicate movements deep in the night sky. We are talking about tracing spatial shifts so unimaginably tiny that they are mathematically measured in micro-arcseconds, an optical feat roughly equivalent to successfully spotting a small coin resting on the surface of the moon from all the way down here on Earth. Using this magnificent, planet-sized eye, they tracked glowing cosmic beacons called masers, which are entirely natural, intensely bright radio signals emitted by warm gas clouds lingering around newly born stars. Over long, patient years of observation, astronomers watch these tiny beacons slowly inch across the sky, mathematically measuring both their proper motion and their radial velocity, whether the light was coming toward us or moving away, to construct a completely full, three-dimensional picture of their motion. As they tracked these glowing beacons closer and closer to the heavily shrouded heart of the galactic center, something deeply terrifying and deeply obvious finally emerged from the data. The celestial objects orbiting near the very center of our galaxy were whipping around at absolutely insane, incomprehensible velocities. But here was the chilling kicker. When scientists calculated the mass of the region, there was absolutely not enough visible matter there to explain that kind of crushing gravity. There were millions of stars, yes, and thick mountains of dust and gas, but it was not nearly enough to hold things together at those blistering, frantic speeds. Something massive and completely invisible was silently anchoring the entire galaxy. All that dizzying motion, all that complex math, and all those precise global measurements perfectly pointed to one specific, deeply mysterious place in the dark. A compact, unimaginably dense spot located near the constellation Sagittarius. This terrifying silent anchor is known to science as Sagittarius A star. Through the VLBA observations, what they finally found hiding in the dust was a relatively motionless object that absolutely everything else in the galaxy was frantically spinning around. Its staggering mass was calculated to be over 4 million times that of our Sun, yet its physical size is impossibly compact, measuring much smaller than the tight, blistering orbit of Mercury. The only physical entity in the entire realm of physics that perfectly fits those nightmarish numbers, something that small, that unbelievably dense, and that crushingly massive, is a supermassive black hole. It sits incredibly quietly in the absolute center of our world, barely flickering in the dark, while every single star, every wandering planet, and every sweeping gas cloud in the entire Milky Way swirls helplessly around its invisible maw. And yet, even as we are safely tethered to this sleeping monster, our galaxy itself is absolutely not sitting still in the larger void. Because while the expansive, overwhelming majority of the distant universe is rapidly running away from us in a great red shift, there was one specific, massive structure that completely stood out from the fleeing crowd. It was our familiar, beautiful, spiral-shaped neighbor, the Great Andromeda Galaxy. In the year 1912, an American astronomer named Vesto Melvin Slipher pointed his telescope at the glowing heart of Andromeda and carefully measured its delicate light spectrum. At that specific time in history, people were just beginning to truly understand exactly how the phenomenon of redshift and blueshift worked with distant galaxies, and what Slipher saw hidden in the light went against absolutely everything they logically expected. Instead of being stretched and redshifted like almost every other distant galaxy they observed, Andromeda's soft light was distinctly blue-shifted, mathematically meaning that it was aggressively heading straight toward us through the dark. Fast forward 100 years, and our advanced space telescopes, massive supercomputers, and global radio dishes finally pieced together the completely full, three-dimensional map of its terrifying trajectory. The modern data definitively confirmed it. Andromeda is absolutely not just casually drifting near us in the void, and it is firmly not going to simply slingshot peacefully past our home. It is securely locked in, set on a direct, unavoidable collision course with the Milky Way, and we are blindly racing toward it as well. Right now, as you listen to the quiet rhythm of your own breath, the Andromeda Galaxy is ruthlessly moving at roughly 110 kilometers per second, directly in our direction, which translates to a speed of over 400,000 kilometers per hour. And the massive Milky Way is absolutely not sitting still either. We are actively drifting toward Andromeda at nearly 300 kilometers per second when you mathematically factor in the combined motion of our whole local group of galaxies. That terrifying math means that the dark, empty gap between us is rapidly closing at roughly 500 kilometers every single second. Still, it is vital to gently remember just how deeply, unimaginably big space truly is. Andromeda is located roughly 2.5 million light-years away from our fragile eyes, a distance roughly equivalent to 24 quintillion kilometers, a number so staggeringly huge it barely feels physically real to the human mind. At that current, blistering rate of speed, even with both massive galaxies barreling aggressively toward each other in the dark, the closing speed is absolutely not enough to make this monumental cosmic meeting happen anytime soon. So, you can rest peacefully knowing it will not happen tomorrow, and it will not happen next year, but in a distant future, roughly 4 to 5 billion years from now, the two absolutely largest galaxies in our neighborhood will finally, inevitably, meet in the dark. Now, your sleepy mind might instantly picture this profound event as a violent, apocalyptic galactic car crash, filled with burning stars violently smashing into other stars, creating chaos and screaming fire everywhere in the void. But that is simply not how gravity and the vast emptiness of the cosmos actually work. Galaxies, despite their brilliant, glowing majesty, are almost entirely made of completely empty space. The billions of stars trapped inside them are incredibly, unfathomably far apart from one another. On average, the sheer distance between stars in our specific part of the Milky Way is roughly 4 to 5 entire light years, which is nearly 40 trillion kilometers of absolutely nothing. Even densely packed in the crowded, glowing core regions of the galaxy, the stars are still typically separated by about a light year or vastly more. To give your resting mind a beautiful sense of scale, if our massive burning sun were dramatically shrunk down to the exact size of a small plastic ping-pong ball, the absolute next closest star would logically be another tiny ping-pong ball resting several hundred kilometers away. Because of this breathtaking emptiness, even during a completely head-on, catastrophic collision between two massive galaxies, the overwhelming majority of the stars will simply drift silently past one another without ever physically touching, exactly like lonely ghost ships peacefully passing in the thick fog of night. Still, this grand meeting will not be completely without consequence. A very small number of stars, especially those trapped in the densely crowded central core, might actually physically collide, while a handful of others lingering on the fragile outskirts might get violently flung entirely out of their home galaxies, tossed aggressively into intergalactic space exactly like desperate cosmic castaways. But the true, magnificent drama of this event happens entirely through the invisible, warping power of gravity. That silent force will beautifully and brutally stretch and warp the two spiral galaxies, violently flinging out incredibly long tidal tails, which are massive, glowing streams of millions of stars pulled unimaginably far from their original homes. It will ruthlessly rip apart the elegant, sweeping spiral arms we have known forever, slowly pulling the two massive glowing cores closer and closer together in the dark, until the two entire galaxies finally, exhaustingly merge into one single, much larger, and significantly messier star system. But this full apocalyptic collision absolutely does not happen all at once in a single flash of light. The very first dramatic encounter is incredibly fast, a dizzying close pass that violently starts the gravitational chaos. But the majestic merger itself is beautifully, agonizingly slow, an event that will take roughly 1 to 2 entire billion years to fully settle down into peace. It is absolutely not a violent crash. It is a stunningly slow, deeply graceful, gravitational ballet unfolding over eons of time. And when that ancient, billion-year dance finally ends, something entirely new will be born from the ashes. A single, incredibly massive elliptical galaxy will take its grand place in the void, a cosmic structure that astronomers have already affectionately given a name, Milkomeda. It will absolutely no longer look like a beautiful flat spiral. Instead, it will be vastly puffier, significantly rounder, and resemble a huge, glowing, formless ball of ancient stars, cold gas, and drifting dust. Our own tiny familiar sun, safely assuming it manages to survive this billion-year ordeal, will very likely find itself trapped in an entirely new, alien orbit. It will definitely not be located where it is today, nestled safely in a neat, sweeping spiral arm. It could easily drift vastly farther from the new, merged center, traveling in a strange, silent path that is far more elliptical and vastly more erratic than it is now, wandering forever through a completely unrecognizable, glowing sky. But the slow billion-year dance between the Milky Way and Andromeda is absolutely not the whole, terrifying story of our journey through the dark. It is merely one small, localized eddy in a vastly larger, more majestic cosmic ocean. Because our beautiful glowing galaxy, along with Andromeda and hundreds of other galaxies floating near us, are all being continuously pulled not just toward each other, but relentlessly toward something fundamentally larger and infinitely stranger. To truly understand exactly where we are ultimately headed, we have to gently let go of our immediate surroundings and zoom way, way out into the dark. We must mentally travel first past the familiar warmth of our solar system, then glide past the dusty glowing edges of the Milky Way, and then drift even past the entire local group of galaxies that we safely call our neighborhood. Because in the grand sweeping architecture of the cosmos, galaxies absolutely do not float in complete, lonely isolation. They constantly gather, they cluster together in the dark, and they faithfully follow the invisible pull of gravity exactly like water flows downhill. Let us start relatively small in this terrifying expanse. Our home, the Milky Way, is an integral part of a gravitationally bound galactic group, a quiet collection of around 80 or so distinct galaxies, affectionately called the local group. This sprawling celestial neighborhood gently spans about 10 million light-years across the freezing void. Within this quiet pocket of space, the Milky Way and Andromeda reign supreme as the two absolute biggest galaxies in the entire group. Each of these massive spirals is beautifully surrounded by a handful of much smaller, orbiting satellite galaxies, like the glowing Magellanic Clouds hovering near us, or the tiny companions known as M32 and M110 faithfully orbiting Andromeda. But this entire massive group of 80 galaxies is only a tiny, insignificant pocket of the absolute next step up in the cosmic hierarchy, a massive galaxy cluster. Galaxy clusters are unimaginably huge, gravitationally bound collections composed of multiple, separate galaxy groups drifting together. Our entire local group is just one extremely small, unassuming member of the massive Virgo cluster, a vastly bigger and more chaotic collection of over 1,000 individual galaxies swirling in the dark. The heavy glowing heart of the Virgo cluster sits roughly 65 million light-years away from our fragile eyes, and it constantly, relentlessly pulls on our entire neighborhood with its massive gravity. And we are absolutely not just peacefully floating alongside it. Our entire local group is actively moving toward the dense, heavy center of the Virgo cluster at a breathtaking speed of about 600 kilometers every single second. So, as you lie completely still, you are inside a solar system, inside a galaxy, inside a group, inside a cluster, all of it rushing silently through the night. But even these massive clusters are not the end of the terrifying story. When immense clusters of galaxies physically group together, they form superclusters, which are currently the absolute largest known physical structures in the entire observable universe. These colossal webs of light can easily span hundreds of millions of light-years across the black void and contain tens of thousands of individual galaxies trapped within their glowing threads. Our specific, local supercluster is a magnificent structure called Laniakea. That beautiful, poetic word translates to immense heaven in the Hawaiian language, and the name fits its terrifying majesty perfectly. Laniakea is absolutely colossal, spanning over 500 million light-years across the freezing darkness. It is the sprawling gravitational home to roughly 100,000 entire galaxies. This immense heaven includes our familiar Virgo cluster, the distant Hydra Centaurus supercluster, the Pavo Indus supercluster, and the Southern supercluster, all deeply interconnected in a brilliant, glowing web of slow cosmic flows. But as we drift through these terrifying numbers, a quiet, completely logical question might naturally arise in your sleepy mind. How do we even possibly know all of this is true? How do fragile, short-lived scientists, standing on a tiny spinning rock figure, out precisely where tens of thousands of distant galaxies are going, exactly how fast they are moving, and exactly what they might be silently heading toward? It all comes down to the meticulous, incredibly patient measurement of motion. Over the past few quiet decades, dedicated astronomers did not just passively look at where these distant galaxies are currently sitting in the dark. They systematically mapped exactly how these galaxies move. And to successfully do that across such impossible distances, they desperately needed far more than just the simple optical tricks of red shifts and blue shifts. They needed to carefully isolate something called peculiar velocity, which is the actual physical sideways motion of a specific galaxy relative to the general, unstoppable background expansion of the entire universe. Now, calculating this specific motion is absolutely not an easy task for the human mind. You cannot simply take a flat, photographic snapshot of the night sky and instantly know how fast a glowing galaxy is going sideways through the three-dimensional space. You have to intelligently combine a vast array of complex observational techniques. One of the absolute most important tools they developed is known as the Tully-Fisher relation. This is an elegant mathematical method where astronomers carefully compare a distant spiral galaxy's visible overall brightness with exactly how fast it physically rotates on its axis. If you can mathematically determine exactly how bright a galaxy should logically be based on its spin, and then carefully compare that true luminosity to how dim and fragile it actually looks from our distant vantage point, you can highly accurately estimate its exact physical distance from Earth. And once you securely know both the galaxy's expansion redshift and its true distance, you can elegantly figure out if it is drifting through space faster or significantly slower than the general Hubble expansion of the universe dictates it should be. That tiny mathematical difference between expectation and reality is its peculiar velocity. It represents the hidden motion actively caused by local, invisible gravitational influences, rather than just the general, expanding fabric of the cosmos. That subtle, drifting motion is exactly where the deepest, most terrifying insights about our universe finally come from. Enter the massive, monumental scientific efforts known as the Cosmic Flows surveys. Cosmic Flows 2, and eventually the much more intricate and highly detailed Cosmic Flows 3, were unimaginably massive global efforts to carefully gather both precise motion and distance data for many thousands of distant galaxies. To build this map, they used everything from the Tully-Fisher relation to measuring surface brightness fluctuations, and even meticulously tracking the dying light of distant supernova explosions. Through decades of patient work in the cold night, scientists effectively built a massive, three-dimensional velocity map of our entire cosmic neighborhood. They mapped not just where the glowing galaxies are suspended in space, but exactly how they are actively moving together as a system. And what they ultimately found completely shattered their expectations. Galaxies were absolutely not just peacefully expanding outward in all directions like unconnected dots drawn on an inflating balloon. They were also clearly, undeniably flowing together in one very specific, highly deliberate direction, moving collectively towards something hiding in the dark that we could not directly see. And this massive cosmic flow was absolutely not random or chaotic. It was incredibly coherent, highly structured, and formed a unified, terrifying motion that stubbornly pointed straight toward a deeply mysterious zone of deep space, located somewhere distantly past the constellations of Centaurus and Norma. But when they tried to peer into that specific spot in the heavens, they found that it was completely, frustratingly blocked from our view by the Milky Way's extremely thick, choking dust lanes. That is when the true, profound mystery of the dark flow really started. What incredibly massive entity are we being pulled toward, and exactly why? Sharp-eyed astronomers had quietly noticed this strange, uniform flow of galaxies back in the 1970s. They observed that countless galaxies, absolutely including our own, were not just passively drifting outward with the expanding fabric of the universe. They were actively moving sideways with intense purpose, flowing at hundreds of kilometers per second, absolutely all of them heading in the exact same mysterious direction. But whenever optical telescopes eagerly tried to look that specific way to see what was pulling them, they violently hit a visual wall. This murky hidden region in the night sky came to be dramatically called the zone of avoidance. It is heavily, densely packed with billions of local stars, cold gas, and thick dust entirely from our own Milky Way galaxy, actively acting as a blindfold and completely blocking our view of absolutely whatever is lurking directly behind it. Still, the collective rushing motion of the universe in that direction was entirely undeniable. Scientists dramatically called the invisible, pulling source of this massive dark flow the Great Attractor. Absolutely not because they could clearly see it, but strictly because they could profoundly feel its terrifying gravitational grip stretching across the cosmos. Entire, massive clusters of galaxies were physically leaning and falling toward it, and we were helplessly caught in that exact same dark cosmic current. Bit by agonizingly slow bit, by cleverly using advanced X-ray telescopes and deep infrared surveys that can successfully pierce the dust, astronomers finally began to carefully piece together the terrifying picture of the hidden dark. They eventually found absolutely huge, incomprehensible concentrations of mass, quietly hidden right behind the Milky Way's obscuring disk. It was absolutely not a single, lonely object, but a vast, terrifying region of open space, absolutely teeming with massive galaxy clusters. One of the absolute biggest structures they uncovered in the dark was the Norma cluster, located roughly 220 million light-years away from our fragile home. And that massive, heavy cluster was absolutely not sitting there alone in the void. It was just one central part of a much larger, infinitely more terrifying structure. This entire hidden region, this incredibly massive attractor, turned out to sit directly near the edge of something vastly, unfathomably bigger, the Shapley supercluster. The Shapley supercluster is currently recognized as one of the absolutely largest known superclusters of galaxies in the entire local universe. That is exactly what is silently pulling us through the dark while we sleep. The sheer gravitational influence of the massive Shapley supercluster is so incredibly strong and so deeply profound that it completely bends and warps the physical paths of tens of thousands of galaxies across a wildly wide stretch of the entire cosmos. Even though we completely cannot see it directly in normal visible light, its unimaginable, crushing mass is ruthlessly dragging our entire, massive supercluster toward it in the dark. We are helplessly moving at roughly 600 kilometers every single second directly in its path. Now here is where the beautiful, terrifying cosmic dance gets even trickier. This journey is absolutely not a neat, clear-cut destination with a solid floor. We are absolutely not simply falling cleanly into the Great Attractor, exactly like a heavy rock falling helplessly into a deep hole. We are actively caught in a massive, unimaginable cosmic tug of war. Because gravity absolutely does not just actively pull things toward it. It fundamentally warps and shapes the entire fabric of space itself. So, while the massive Great Attractor relentlessly pulls us in one direction, entirely other invisible forces in the universe are also violently shaping our exact path through the void. And one of the absolute strangest, most deeply mysterious forces shaping that exact path is mathematically not an actual force at all. It is something hauntingly called the dipole repeller. Let us gently slow this dizzying cosmic concept down for a second and breathe. The dipole repeller is absolutely not a physical object. It is not a massive, glowing galaxy. It is not even a solid thing that you can ever possibly look at or see with a lens. It is simply a vast, sweeping region of open space that is unusually, terrifyingly empty. It is a true cosmic void. There is barely any physical matter there at all. There are absolutely no major, heavy galaxy clusters, and therefore there is absolutely no real gravitational pull originating from that specific area. But that profound, chilling emptiness actually deeply matters, because while incredibly massive objects actively pull galaxies toward them, giant, empty voids act entirely like the exact opposite. They allow galaxies to easily, passively drift away from them because there is no gravity to hold them back. Think of this strange, invisible dynamic exactly like this. Imagine you are peacefully floating on your back in a massive, wide river. Far off on one side, there is a roaring, powerful waterfall, actively pulling you and the water toward the edge. That heavy, violent pull is the Great Attractor. On the exact opposite side, there is just an area of completely flat, entirely calm water. There is absolutely no current pushing you, and no force actively moving you away. That silent, calm water is the dipole repeller. You are absolutely not being physically pushed by it. You are just simply not being held back by it. So, inevitably, the waterfall wins the tug of war. This is exactly what our fragile galaxy is currently caught in. A massive, sweeping kind of gravitational current spanning billions of light years. And dedicated astronomers finally started to see this terrifying reality vastly more clearly in the year 2017, when they meticulously used the cosmic flow's 3D data and constructed stunning three-dimensional motion maps containing over 18,000 distinct galaxies. What they ultimately saw was absolutely not just a simple pull in one singular direction. It was a massive, sweeping dipole pattern. Thousands of galaxies exactly like ours were actively streaming, flowing rapidly away from the empty void of the repeller and rushing relentlessly toward the heavy gravity of the Great Attractor. But even this unimaginable, sweeping flow of thousands of galaxies across hundreds of millions of light years is absolutely not the end of the cosmic motion. When you patiently zoom out far enough, drifting silently past the heavy clusters, moving past the sprawling superclusters, and looking past the glowing filaments and the deep voids, an entirely new, terrifying pattern finally begins to slowly appear. It is a much deeper flow, a fundamental, unstoppable current that gently stretches across the absolute entirety of the observable universe. All the great, glowing threads of the cosmic web are absolutely not standing still. They are all drifting, slowly and inevitably, into an entirely new chapter of the dark. So far in our journey through the dark, we have followed the Earth as it silently spins and faithfully orbits in the deep night. We have watched the heavy sun drift through the glowing galaxy entirely, like a fragile leaf caught in a rushing current. We have zoomed out to witness the massive Milky Way itself, moving as just one small part of a vast, terrifying cosmic flow towards something we cannot even see. It is already deeply, wildly disorienting to realize that we are sleeping on a moving rock, trapped inside a moving system, embedded deeply within a moving galaxy, all of it sliding relentlessly through the dark. But now, as the night deepens and your mind drifts closer to the edge of dreams, it is time to look at the absolute grandest scale of all, and to finally ask the ultimate, most terrifying question. Where is absolutely everything in the universe going? To answer what the final, inescapable destination of reality might be, we must turn our attention away from the brilliant, glowing galaxies and focus instead on something infinitely stranger. We must talk about something that absolutely does not glow, does not shine, and does not cast any shadow at all. We must speak of something invisible that acts entirely as though it is secretly pulling the strings from behind the heavy curtain of the cosmos. Something so profoundly weird and counterintuitive that it violently shook the entire world of science to its very core when we first stumbled upon it in the dark. The story of this invisible monster begins, ironically enough, with an intense desire to mathematically predict the ultimate end of the universe. In the quiet, highly focused years of the 1990s, two deeply dedicated teams of brilliant scientists, one led by Saul Perlmutter and the other by Brian Schmidt and Adam Rees, were intently studying the most violent, explosive deaths in the cosmos. Exploding stars specifically classified as Type 1, a supernovae. These particular, cataclysmic stellar explosions are incredibly, blindingly bright, and they possess a very beautiful, reliable characteristic. They absolutely all explode in roughly the exact same way, reaching the exact same peak of intense luminosity. Because of this predictable, blinding flash of light, they act as absolutely perfect cosmic mile markers burning in the deep void. The logic is beautifully simple. If you know exactly how bright a specific supernova should inherently be, and it looks significantly dimmer than expected through your glass telescope, you mathematically know with absolute certainty that it is simply farther away in the dark. The primary goal of these dedicated teams was incredibly ambitious. They wanted to carefully measure the exact rate at which the entire expanding universe was slowly grinding to a halt. You heard that right. They were specifically looking for the universe to be slowing down. The fundamental, unquestioned assumption held by nearly every mind at the time was that ever since the explosive birth of the Big Bang, the universe had been aggressively expanding outward. But because gravity is a strictly attractive force, it must inevitably be pulling absolutely everything back inward, acting entirely like a set of cosmic brakes, slowly bringing the expansion to a quiet, peaceful stop. But the cold, hard numbers captured in the dark absolutely did not support that comforting, logical assumption. When the teams meticulously measured the fading light of the supernovae, something fundamental mathematically did not add up. The distant galaxies were absolutely not just far away from us. They were far too far away. The ancient light traveling from those dying stars was significantly more redshifted than it mathematically should have been, which logically meant that the galaxies were not just coasting away from us in the dark, they were actively accelerating. The breathtaking, universe-shattering truth was undeniable. The universe was absolutely not slowing down at all. It was actively, violently speeding up. Now imagine being a highly educated physicist who has dedicated your entire life to the laws of gravity, and suddenly realizing in the middle of the night that absolutely every single assumption humanity holds about the future of the universe is completely, fundamentally wrong. That is exactly what happened to the scientific world in the year 1998. And instead of foolishly brushing this terrifying anomaly off as a mere calculation error, the brilliant teams meticulously double-checked and triple-checked absolutely everything. But the relentless, unyielding results kept whispering the exact same terrifying truth. Something entirely invisible, something unimaginably powerful, is actively pushing the fabric of the universe apart faster and faster every single day. Lacking any true understanding of its nature, they simply called this terrifying phantom dark energy. To this very day, as you lie quietly listening to the dark, we absolutely do not know what dark energy is physically made of. We do not even know if it is a physical thing at all, but we do mathematically know that it is entirely real, and it absolutely dominates the entirety of the universe. Roughly 70% of absolutely everything out there, of all the combined energy and physical matter that exists in reality, is dark energy. To truly understand just how deeply weird and humbling that statistic is, carefully think about this. Absolutely everything you have ever seen with your eyes, touched with your hands, tasted, or heard in your entire life. All the burning stars, all the wandering planets, absolutely every single atom in your body and in the ground beneath you, makes up significantly less than 5% of the actual universe. Another 25% of the cosmos is made of dark matter, another invisible ghost which silently holds the sprawling galaxies together with its heavy gravity. And then the rest, the absolute biggest, most dominant slice of the entire cosmic pie, is this silent, expanding force ruthlessly pushing the universe apart. So, what could this phantom force possibly be? This is exactly where the boundaries of human knowledge get incredibly tricky and deeply philosophical. Physicists have a few desperate guesses to explain the darkness. The most straightforward, elegant idea is that dark energy is quite simply the inherent vacuum energy of space itself. This concept suggests that even when a patch of deep space looks entirely, perfectly empty, it is absolutely not truly empty at all. Instead, it is constantly, violently filled with microscopic quantum fluctuations, which are tiny, random, flickering blips of energy continuously popping into and entirely out of existence in the dark. Now here's the incredibly interesting part that keeps scientists awake at night. When you diligently do the complex math, quantum theory actually perfectly predicts that empty space absolutely should possess a baseline energy. That is not the crazy part. The truly crazy part is exactly how much energy it predicts. The mathematical prediction dictates that the vacuum energy of empty space should be 10 to the power of 120 times stronger than the amount we actually physically observe in the universe. In other words, our greatest, most tested quantum theory overshoots the real, observable value of dark energy by a mathematical factor so unfathomably huge that it is widely considered the absolute biggest mismatch between theoretical physics and physical observation in the entire recorded history of science. This mathematical disaster is exactly like trying to carefully measure the weight of a single, delicate bird feather, and your sophisticated calculator confidently tells you that the feather weighs significantly more than the entire planet Earth. Yes, something is profoundly, deeply off in our understanding of the dark. And here's the truly terrifying problem that arises from this. This theoretical vacuum energy, this inherent energy of empty space, is absolutely not just sitting there quietly doing nothing. According to Albert Einstein's elegant, unbreakable equations of general relativity, both energy and pressure actively shape the physical fabric of space-time. Which means that if empty space truly does possess an inherent energy, then that energy absolutely affects exactly how the entire universe expands. That is exactly where dark energy enters the stage. We have clearly, observationally proven that the universe is aggressively expanding faster and faster. So, whatever invisible mechanism is actively causing that terrifying acceleration has to be fundamentally baked directly into the physical structure of space itself. And that is what ultimately led scientists to desperately think that perhaps the theoretical vacuum energy is indeed the very thing relentlessly driving this outward expansion. Maybe dark energy is simply the natural, unavoidable energy of empty space. But if that elegant idea is true, then the prediction made by quantum theory absolutely should match what we physically observe through our telescopes. And it absolutely, catastrophically does not match. It is not just a little bit off. It is completely, fundamentally broken. So humanity is left with a chilling conclusion. Either something is completely wrong with our most advanced, trusted theories of reality, or we are entirely missing a massive, fundamental piece of the cosmic puzzle. Now, as you sink deeper into your bed, let us try to gently picture exactly how this terrifying force operates. Imagine the entire fabric of space as a giant, soft loaf of raisin bread waiting to be baked. The distant, glowing galaxies are exactly like the small, dark raisins securely baked into the thick dough. As the bread is placed in the oven and slowly bakes, the dough naturally expands, and because the dough is growing, the raisins peacefully move further and further away from each other. That is the classic model of the universe smoothly expanding. But now, imagine that halfway through the quiet baking process, an invisible hand violently turns the heat way, way up. The soft dough absolutely does not just continue to rise steadily. It suddenly starts inflating wildly, faster and faster with every passing second. That extra aggressive push, that sudden violent runaway inflation, that is dark energy. And because dark energy is an inherent property of space itself, a deeply terrifying rule emerges. The bigger the loaf of bread gets, the faster it naturally expands. Because dark energy is absolutely not just a substance lightly sprinkled into the void, it literally is the void. The more empty space there is in the universe, the more dark energy there is to push that space apart. It is absolutely not diluted as the universe grows larger. It absolutely never runs out. That relentless, infinite capacity for growth is what makes this force so deeply scary and so profoundly isolating. So now, humanity is standing here on a tiny rock, peering through our glass lenses, looking out at a magnificent universe that is tearing itself apart faster and faster every single day. And the silent, invisible engine behind that runaway, terrifying growth is dark energy, an untouchable, unfeeling force that absolutely does not clump together into beautiful stars, absolutely does not slow down over time, and somehow, impossibly, gets infinitely stronger the more empty space it actively creates. That fact alone is already profoundly weird and unsettling. But now comes the truly, deeply terrifying part of the story. The final question that awaits us in the absolute dark. Where does this relentless, unstoppable expansion ultimately take us? Let us say that dark energy simply keeps doing exactly what it is doing right now, keeps aggressively pushing, keeps relentlessly stretching the very fabric of space. What happens to all the beautiful light and structure of our reality in the impossibly long run? As the night continues and sleep pulls you closer to the void, we will explore the final, haunting destinations that await absolutely everything that has ever existed. This terrifying realization of an aggressively expanding void leads us to the ultimate haunting question of our long journey. If dark energy continues to relentlessly push the fabric of reality apart, what exactly happens in the unfathomably distant future? This line of questioning brings us to one of the most violent and terrifying theoretical predictions in absolutely all of cosmology, a scenario appropriately named the Big Rip. To understand this chaotic end, we must look at how forces battle one another in the dark. In our current, observable universe, the familiar force of gravity is still mathematically strong enough to successfully hold physical things together on a local scale. Because of this gravitational anchor, sprawling galaxies absolutely do not get torn apart. Massive stars still faithfully orbit their galactic centers, and fragile planets stubbornly cling to the warmth of their suns. Even though the empty space between the galaxies is constantly expanding, the binding forces deeply inside those galaxies are currently much stronger than the outward pull of the expansion. But dark energy absolutely does not play by these comforting rules. It constantly grows, it is entirely relentless, and in some theoretical models, it does not merely keep accelerating the entire universe at a steady pace. It actively speeds up the rate of acceleration itself. Imagine that you are sitting quietly inside a metal car that is rolling faster and faster down a steep, dark hill, and then suddenly, without warning, the angle of the hill steepens dramatically into a sheer cliff. That terrifying plunge is the Big Rip scenario. At first, as the acceleration intensifies, it is absolutely nothing that a human observer would easily notice. Massive galaxy clusters would simply begin to drift apart from each other much more quickly. The empty space lying between the Milky Way and Andromeda would aggressively grow so impossibly fast that their grand, billions of years-long collision would be canceled entirely, leaving them isolated forever. But the tearing force absolutely would not stop there. Eventually, as the phantom energy grows to apocalyptic levels, the massive galaxies themselves would begin to physically stretch. They would absolutely not just be pulled entirely apart from their neighbors, but ruthlessly ripped apart from the inside out. The ancient, reliable force of gravity would critically weaken under the strain, and the invisible bonds holding millions of stars safely in their places would violently falter. Then, isolated star systems exactly like our own solar system would completely come undone in the dark. Massive planets would be violently flung entirely out of their stable orbits, drifting helplessly into the freezing void, and ancient moons would be permanently lost from their parent worlds. And still, the invisible tearing keeps going. As the terrifying acceleration reaches its absolute peak, even the solid rocky crust of the Earth itself would absolutely not be safe. The physical force of cosmic expansion would grow so incredibly strong that it would completely overwhelm the fundamental electromagnetic forces that hold solid molecules beautifully together. The planetary crust would aggressively crack and dissolve, and the very atoms that make up all physical reality would violently break apart. Finally, even microscopic protons, the fundamental building blocks of all known matter, could be physically torn to pieces as the absolute fabric of space itself stretches far beyond what any subatomic particle can possibly survive. In the final, chaotic moments right before the Big Rip, the universe would become a blinding storm of disassembled pieces. According to one specific mathematical model, 22 billion years from this very night, there will be absolutely no galaxies, no burning stars, and no solid atoms left. There will only be pure, unbound energy, erratically flickering in an infinite, terrifying sea of absolutely nothing. But that horrific timeline is merely a theoretical guess. It heavily depends entirely on exactly how dark energy truly behaves, a profound mystery that humanity still completely fails to understand. Fortunately for the weary mind seeking rest, not absolutely every scientific theory ends in such a violent, chaotic shredding of reality. There is another profoundly beautiful idea, and it starts with a deeply comforting question. What if the aggressive expansion of the entire universe simply does not go on forever? What if, at some distant, quiet point in the future, the ancient force of gravity finally fights back and reclaims the dark? You see, in the very early days of the young universe, absolutely everything was unimaginably hot and incredibly dense. While space was actively expanding outward, gravity was aggressively pulling back, desperately trying to slow absolutely everything down. That massive cosmic tug of war has been silently going on since the very beginning of time, and for a very long period, many brilliant scientists genuinely thought that gravity might eventually, triumphantly win. This elegant theory is known as the Big Crunch. In this specific version of the cosmic story, the current, terrifying outward expansion is merely a temporary, fleeting phase. One distant day, the invisible power of dark energy might miraculously weaken, or perhaps it was absolutely never a permanent force to begin with. If that shift happens, gravity would slowly, inevitably take control of the void once again. Very slowly at first, it would start to gently pull absolutely everything back together. The incredibly distant galaxies that once drifted so far apart into the lonely dark would begin to slowly close in on one another. The massive sprawling structures of the cosmos would violently reverse their courses, and the great glowing threads of the cosmic web would aggressively contract. Over billions of quiet years, the entire universe would significantly shrink in physical size. Ambient temperatures across the void would drastically rise as absolutely everything gets mercilessly squeezed into a tighter and tighter volume of space. The dark, comforting night sky would rapidly grow blindingly bright, absolutely not from beautiful new light being born, but from ancient, dying stars being forced to violently smash together in a rapidly shrinking, claustrophobic cosmos. The very fabric of space-time would bend sharply inward, exactly like a giant closing fist. In the final, terrifying seconds, the absolute entirety of the universe would violently become a single, unfathomably hot, dense point once again. And then, perhaps, it simply ends. Or perhaps it beautifully, miraculously starts all over again. There is a deeply poetic, comforting symmetry to the Big Crunch, providing the beautiful idea that the massive universe simply ends exactly where it began, suggesting that the original Big Bang was just one single explosive act in an endless, eternal cosmic cycle of expansion and collapse. But there is a massive, frustrating problem with this poetic picture. The cold, hard mathematics absolutely do not line up. Absolutely everything we have diligently observed so far, the dramatic galactic redshifts and the ancient glow of the cosmic microwave background, definitively tells us that the universe is absolutely not slowing down. It is aggressively speeding up, which means that gravity is absolutely not winning the war. So, unless the fundamental nature of dark energy changes completely and dramatically in the distant future, the Big Crunch absolutely does not seem mathematically likely. That leaves humanity with one absolute final possibility, one ultimate future that is mathematically supported by the absolute best data we currently possess. It is an ending that is absolutely not as dramatic as a violent rip, and it does not feature the fiery collapse of a crunch. It simply, quietly keeps going. And for a mind seeking rest in the dark, that might be the absolute most haunting, peaceful ending of all. This final destiny is known to science as the Big Freeze. It describes a vast universe that absolutely does not die in sudden violence, but slowly, gently fades away in absolute, eternal silence. According to current, rigorous cosmological parameters measured by sophisticated tools like the Planck satellite and large-scale surveys, the steady rate of cosmic expansion is perfectly consistent with a cosmological constant. That complex term mathematically means that dark energy very likely stays completely the same over vast stretches of time. It absolutely does not increase its power to rip us apart, and it absolutely does not decrease to let gravity win. It just quietly hums along, gently and endlessly stretching the fabric of space. If that elegant mathematical assumption holds true into the dark, then the Big Freeze is absolutely the most mathematically likely ultimate fate of our universe. Let us zoom completely out and peacefully follow this endless, quiet future, step by step, into the absolute dark. Right now, in the vibrant present day, beautiful galaxies are still relatively close together, and warm, glowing stars are actively being born in places exactly like the Orion Nebula. Massive black holes are still actively eating, and the grand cosmic web is still beautifully glowing with ancient energy. But as deep time relentlessly passes, the universe will completely change. Give it 100 billion long, quiet years. By then, the entire observable universe, the absolute limit of what we can possibly see, will mathematically shrink dramatically. This happens absolutely not because the universe itself is physically getting smaller, but because the vast empty space lying between us and those distant galaxies is actively expanding significantly faster than the speed of light can ever possibly cross it. Those beautiful distant galaxies will slowly, silently slip entirely beyond our cosmic horizon. They will absolutely still exist in the dark, but they will be forever placed out of our reach, exactly like silent ghost ships sailing quietly over the terrifying edge of an ocean that absolutely never ends. After enough patient time passes, even the absolute nearest galaxies will completely vanish from our view. Eventually, the Milky Way and Andromeda, by then long since violently merged into one giant, lonely elliptical galaxy, will become a completely isolated island, safely floating in a pitch-black, entirely silent sea. The beautiful, chaotic process of star formation absolutely will not last forever. Burning stars desperately need thick clouds of cold gas, mainly hydrogen, to be continuously born, but that precious drifting gas absolutely does not last infinitely. Current astronomical estimates dictate that in roughly 1 trillion years, absolutely all new star formation across the entire infinite universe will completely and permanently stop. The ancient stars that are left behind will slowly, quietly burn through their remaining fuel. Tiny, incredibly cool, and deeply dim stars known as red dwarfs can safely last for trillions of years, and they will stubbornly serve as the absolute last fading beacons of light in an otherwise terrifyingly dark sky. But eventually, even these stubborn embers will completely burn out, leaving the universe totally dark. After that final light fades, we will peacefully enter what scientists call the degenerate era. During this unimaginably long epoch, there are absolutely no new stars, and there is absolutely no new light anywhere in existence. The massive universe is composed entirely of completely cold, collapsed objects, frozen brown dwarfs, and completely silent, sleeping black holes. And time simply keeps stretching forward. Over the mind-bending span of the next 10 to the power of 40 years, which is a single number 1 followed by 40 zeros. These heavy dead stellar remnants will slowly decay into the void. The silent black holes, however, possess their own agonizingly slow clock. According to the brilliant mathematics of Stephen Hawking, black holes are absolutely not permanent features of the void. They slowly, quietly evaporate through a subtle quantum effect called Hawking radiation, which causes them to continuously lose their heavy mass over incomprehensible stretches of time. A black hole possessing the exact mass of our warm sun would take approximately 10 to the power of 67 years to completely vanish into the dark. Let that absolutely staggering number sink deeply into your sleepy mind. Our entire magnificent universe right now is roughly 13.8 billion years old, and that vast span of time is absolutely nothing compared to the terrifying scale of time we are currently talking about. In the gentle fade of the Big Freeze, time itself stretches far beyond absolutely everything we can truly, physically imagine. Eventually, absolutely every single black hole safely evaporates into the dark. One by one, they silently disappear in tiny, completely invisible flashes of radiation. There are absolutely no more stars, absolutely no more planets, and absolutely no more light anywhere in the cosmos. The universe peacefully becomes a quiet, empty place of solitary particles floating entirely alone in an infinite sea of completely cold, continuously expanding space. The ambient temperature gracefully drops down toward absolute zero, entirely because there is absolutely nothing left to ever generate heat. Even the protons themselves might absolutely not last, eventually falling completely apart and leaving absolutely nothing behind. What is finally left at the end of eternity is just a ghostly whisper of radiation, a completely invisible, freezing void that once burned with the magnificent fire of a trillion stars. The beautiful mathematical laws that originally gave birth to absolutely everything will still remain quietly etched in that frozen void, even if there is absolutely no one left to ever read them. And perhaps, as you finally surrender to sleep, there is a profound, beautiful comfort to be found in that ultimate silence. The frantic, rushing motion of the cosmos will eventually come to a perfect, peaceful stop. The grand, turbulent dance of the universe will finally find its rest. You absolutely do not need to worry about the unimaginable distances or the pulling currents of the dark tonight, because right now you are safe, you are warm, and you are entirely free to gently let go of the waking world. Thank you for traveling with us through the deep currents of the night. If this journey has brought you a sense of calm, please subscribe to Bedtime Universe and allow us to explore the beautiful dark with you again tomorrow. Until then, close your tired eyes, surrender to the gentle, unseen motion of the world, and sleep well.